Welcome back to Factoring Quadratics. This is my second video. Today we're going to talk about and kind of focus on perfect squares. So we can think about perfect squares. That's the approach we're going to take. Now, so if I got x squared plus 8x plus 16, my first instinct, and this is going back to factoring, is I want to take the 16 and make it 4 times 4 because that's a perfect square. Now, look at these factors. Since that is a plus 16 and that's a plus 8, I know that 4 plus 4 gives me that 8. So I could say x plus 4, x plus 4. I mean, we can FOIL that out and check it, but now some of us may be asked to even put it in this form right here. How many x plus 4s do we have? We have 2, so we square it. This is a perfect square. What about when you have x squared minus 10x plus 25? This too is also a perfect square. Now notice something. Notice that since this is a plus 25 and that's a minus 10, I need to take the negative 5 and negative 5 to give me a negative 10. So that's x minus 5, x minus 5. And since I've got 2 of these, we can simplify this down to x minus 5 squared. Now, I think the perfect squares, in my opinion, are pretty easy because that's what I always look for at the beginning of any of these factoring. But now, what about if you get a problem just like this? Now, notice this is different because this does not have that middle term. It does not have something x. But is 81 a perfect square? It is absolutely. Now, I will get students that will say, okay, that has to be, well, since that's negative, they're both x minus 9. Well, think about this. If you FOIL this back out, negative 9 times negative 9 gives you a positive 81. This could not work. So then we're saying, okay, well, maybe we use x plus 9, x plus 9. Same thing, the 9 and the 9, if you add or multiply it together, you get a positive 81. That does not work. So this is a perfect case where if there's not a middle term, that means they cancel each other out. So that means since there's pretty much a 0x right here, I mean, really there's a 0x, that means one's going to have to be positive 9, the other one has to be negative, because what is 9 minus 9? It's 0. It cancels each other out. So if we actually FOIL this out to check it, x times x is x squared. X times negative 9 is negative 9x. 9, if you go under, times x is 9x. And then 9 times negative 9 is negative 81. So then notice this. When these cancel, what's left? X squared minus 81. That's our original problem. We do the same setup if you see a perfect square with nothing in it. Let's take a look at this. So take a moment and see x squared minus 49. Well, that is a perfect square. Since there's no middle term, I know it's going to be x plus x minus. And it's going to be 7 on both. Plus 7 and the minus 7. Now, if I give you a problem like 121x squared minus 144y squared, we need to think about perfect squares. Well, look at this. That's a perfect square, 11 times 11. The x is, since it's x squared, you got a perfect square. And the 144 is 12 times 12. And then you've got a perfect square, y times y. So what we need to do is we need to come up with a good factor. Well, they have 11 and 11, because 11 times 11 gives me 121. We have an x times this x gives me x squared. Now, since this is a minus sign, one's going to be plus, one's going to be minus. Now we've got 12 and y. That would be my answer. 11x plus 12y times 11x minus 12y. And we have to be very, very cautious on this one. What do they have in common? Well, they have this x in common. So I'm going to pull the x out, and I'm left with 25y squared minus 9. Now, that breaks down to 5 and 5, y and y, and 9 is 3 and 3. So I'm going to have x. That means I'm going to have 5 and a 5y. Since that's a minus sign, I'm going to have a plus and a minus. A plus and a minus. And that 9 is a 3. And you can always go back and FOIL this out to make sure that this is correct. Now, what about if you have a fraction? Well, we treat this the exact same way. Look at the 16, look at our denominator. 16 can be broken down to 4 and 4. So since there's not a middle term, I know this is going to be x. Since that's a minus, x minus something, x plus something. Now, since that breaks down to 4, it's not a 4, it's a 1/4. And notice if I FOIL this out, the 1/4 and the minus 1/4 cancels each other out. Now, what about if you have an x squared plus 64? Okay, that is a perfect square. Now, I've seen this a lot. Okay, since that's plus, so it's plus 8 plus 8. And then I'll say, well, I'll have some that's minus 8, minus 8. And then some I'll have a combination. Well, let's kind of rule some of these out and see. Okay, if you have an 8 and 8, that does give you 64. But think about this, you have 8x plus 8x. You would have a 16x if you FOIL this out. This would not work. Same thing with this one. a -8 and a -8 gives you a positive 64. But then when you would FOIL this out, you'd have a -8x and a -8x, which would give you a -16x. You don't see that on this problem. So I would rule this out. And finally, this one right here is the more logical one, because if you FOIL this out, you would say x squared minus 8x, go under plus 8x, and then 8 times -8 is -64. And then we cross out the x's because they cancel. But look at this. So since this cannot be factored, we call this prime, or not factorable. So anytime you have a perfect square with a plus in front of it, it's not going to be factorable. And finally, take a look at this one. This is the same concept, except with a fraction. The 9 breaks down to 3 and 3. So this would be x plus 1/3. But then, I mean, it's the same concept. I mean, I'll get this right here. Then I'll also get a minus 1/3 on both. And then I also will get one of each. But remember, the only difference between this one and the previous one is a fraction. Well, it's in the same format, so this is also prime or not factorable as well. So I hope this does help. Be looking at later on for my third and final installment of factoring quadratics. Thank you very much.